This video is to show the different features of KherveFitting version 1.54. So in here I have a file made of 3 samples, and we can go into the sample manager, and in the sample manager has been quite well improved. So now we have new icons, the smooth, so we can add a smooth to each core levels. We can multiply the intensity by 1,000, or we can use the stack fitted plot. And that's the main feature of version 1.54. So for example, in here we have a carbon 1s fitted with 4 void peaks on a background of a Tugar background. So you can plot them like this using F2. You could normalize it from binding energy, then using the shift you can normalize to this one, normalize to that one, and so on. So that's available, was there before. You can just normalize to the maximum intensity, or you can use the stack. If you double click, you can get more of the stack. But then the new one is this one here, which create a stack fitted plot, which provide kind of a publishable data straight in one go. And I would recommend to use this feature together with an export of an SVG, and then using programs like Inkscape, which only works with SVG. And with this, you can modify all features, the text and the colors and everything. So together, KherveFitting plus Inkscape will give you a very nice plot. So that's now available. The next feature is now you can't change the name. So if you double click, you can't change the name. And that's because it was creating mistakes every time you wanted to plot and it didn't work. So now single click, it does a quick plot. Double click, do the proper plot. Okay, so that's now available. Then I should mention the binding energy corrections, because the binding energy corrections that is done here is good, and it works not just for a single sample, it works for multi-samples. So it's independent of the sample in row 1 and row 2. For example, for this one, it will look for the carbon 1s CC in here. On the carbon 1s CC, the default value is shown in instrument settings, and that's 284.8. You can change it to whatever you like. I've chosen 284.8. And if I now click here, it will move this one by minus 0.03. And that's it, that's done. I didn't need, so I can reinitialize, so put that back to 0, maybe click on the plot, and now it's all back to 0, and it's back here. But I can be on this plot, oxygen 1s, we click, and he still find the carbon 1s, which is on a different plot, so he knows. And he knows this row looking for carbon 1s CC. I can do this here, so that was 284.63, now it's 284.8. I go to the next one, it's also now 284.8, and the values are all shown here, and you can then plot all those together, and that gave a proper shifted multi-samples, all done very easily. And that is nice feature. Also, it does not change the raw data. So this value is actually added later on in the Excel file as a column. So you can exactly see the difference. Okay. Then another feature that was added is the conversions. So you can now convert samples not just one at a time. So this is an Avantage file, for example, but it could be an MRS file. It could be something with single plots. So this is a single file made from Thermo Avantage and having these core levels. So in the past, you would just drag this one in the plot and be done, but now you can drag the 3 together, and then he will do his conversions, and he goes 3 times, and then he opened the last one that we can see here, and those are the KherveFitting created, and he also created KherveFitting JSON. And then with this, you can do the same, because it's the multiple samples is done for all types of file types, MRS, as I said, on the others, but you can do multiple curve fitting samples. And that way I will show you, you can also do it with fitted data. So for example, this is a single file and not yet fitted, but if I was to fit this one very quickly with something, a background or something like that, then you will understand. So let me just quickly do something here that I've seen. So let's say this was this one, sorry, yeah. So now you have the carbon 1s. If you want to pick fit this, let's open that. Let's do arrange. Let's create the background. And by the way, the background now is much better than before, so it's much more stable. It will come even better in your next version. This is the one I use, where now this is using the LM-Fit XPS. So, and you can't go higher than the data, and it will not diverge, so it will be better for noisy data. So let's say this is my data. Maybe let me just move that somewhere here, and I will create some GL, very quickly GL data. And you can see, by the way, there is the colors is like this. It's because I've said yes to the oh, I dismissed the registering, so it's doing that. But if I just click preference, the data is coming back. So just need to make sure I have done that. And then in here, I will also try to fit it nicely by using the same LG ratio and the same width. So I put them all in function of A. I fit this. Now you have kind of fitted data. Okay, just fitted data. I save that. And what I want to show is now if I use the KFitting Excel, those ones, I put them together, then I'm creating a single file and I will call it test. A single file, it's going to happen, made of all those files. So 3 files into one, and that enable you to compare. And even, and that's what I was trying to show, even the pick fitting is preserved. So we'll need to find it though. But this is, yeah, that's it. This is this one. So it can preserve the pick fitting if you've done already the pick fitting in one of those. Okay, so this is a nice little feature. I've also added the RSF, and this will be later on using the NPL transmission, but I've not done it yet. The next bit I need to do is finishing the export of CASA VAMAS file, and this is because I'm going through a philosophy. If I just go to help about, you're going to see this version log, and the version log will give you first what I've done the previous times. So that goes down to version 1.0. So I'm at version 1.505, but the philosophy here, to finish version 1.6, I need to make it fully compatible with importing and exporting fitted CASA XPS files, so VAMAS file. That's what I want to do. So for now, if I show you what has been done, let me open my CASA. So this is a CASA, and then I have here, for example, the Oxygel 1S. If I let me find it, so this is my VAMAS file shown here, and it is that one. So that was saved like this, and you had here, you had two components. one an LA50 and one an SGL20, and that's just to show that you can do it. And as long as those pics are named differently, you can save it to, for now, you can save it to KherveFitting. Later on, I think it won't matter what name you give, KherveFitting will just do it by itself. But for now, there is a bug if you don't change the name. So let's say now, this is this file, as I explained, and we have not something nicely fitted, but something like that. If I put it in KherveFitting, this is KherveFitting, and that's the VAMAS file. If I put that, it's going to import the VAMAS file. It may import it incorrectly first, and you will see it maybe in here. No, okay, it's good. And you can see that there, it also exported the fitted data. And the fitted data, we had an LA50. And if I open slowly this one here, you have in here another button that was always there, but you can actually select the different type of model if you want to change them. But this has been imported with an LA50. And an LA50 is actually a 2 in the gamma, because actually you have to make it more and more to change the power, and that's done using those types. Okay, so that's done with a 2. And then a standard, yes, it's done with a 2 power. So it's an LA of the power 2. And then the SGL is done at 20%. So it's almost a good like for like. And the next bit is, for example, now if we go to Carbon 1S, you have this data. And the data, just to show you how properly to import it. So let's say it start around there. 752. You see the 752 shown here. This is the start of the data, 757. And if we were to go into the data file for Excel, because 757, if I now go to Carbon 1S, you're not going to find 757. It's shown here. Yeah, but it's 14,000. Okay, this was 7. Yeah, so you have to go into the Excel to understand what was done. And in KherveFitting, and if I go back there, you have this 7, 5, or 4, 3 that was used. This is the raw data. And then you have a transmission function. And you have to divide the raw data by the transmission function. And that's when you get this corrected data. So it's all done exactly like CASA, except that CASA shows the raw data and actually it fits the raw data. It doesn't divide by the transmission. Later on, it will divide by the average transmission, as far as I know. But that's not done in KherveFitting. We divide straight every point by their corresponding transmission. So that's what we get. I want to show again. Let me get Casa. Yeah. So this was 752. Yeah, shown here. And 752 is shown, I mean, it's close to 752. It's actually 743. The transmission is now, if I go here and go into the transmission, then we have the transmission here. It looks like 50, 60, 50, 65, but actually when we click, we get 0.05063. It was shown here. I'll show again, 0.05063. And in here, this is what you get, 0.5. So that's why we get this 14,000. So that's why it looks different, but actually it's the same. Okay, and it's not done yet on the export, because in the export, for now, I export straight away the corrected data. So that's why it will look quite different. Okay, so, but what I've done with the export, because you can export now VAMAS, you can see here the export VAMAS. If I now, let's say, change the fitted file, I will move this one somewhere else, so to show that something has happened. Okay, so this is my LA50. And I moved it, and I'm going to export that into a VAMAS. And I will call it test convert. Nope. Okay, so that's it. So I'm going to convert it as number 2 now. So we can open it in VAMAS. So basically what we are doing right now, we are exporting an Excel file into a VAMAS file. That's what we are doing. And it's happening in the background. I just didn't remove the pick fitting, so you could not see it. I may just redo it quickly. And we call it the same thing. Yes, replace. And it does this writing block and it saves successfully. Okay, so what have we done? If we now go to VAMAS and we open the number 2, number 2 should be here. Yeah, that's it. And now maybe I'll remove this transmission first. Okay, that's the number 2. I drag that in there, and now we have, yes, still some problems. Somehow it created a Shirley background in here. That will be removed later on. But this one, as you can see, it created this LA50. I will show you that this is LA50, and this SGL20 is conserved. So you kind of have, and you can still move it and still fit it. And so somehow you get from KherveFitting, from VAMAS to KherveFitting, and from KherveFitting to VAMAS. The only issue left is the intensity for exporting. That's what is new in KherveFitting version 1.54. There is more that was done on the constraint and on the pick fitting. For example, in here, when you pick fit, now you can't change anything. It's just stuck until the current fit is complete. On many more things, but they are not important. They are just bugs.